And that's when the words popped into my head. You know, every piece of data that arrives is the question. It's kind of like, think of sense making. It's like, as fast as the days are arriving, you're seeing how it fits in the puzzle, and you can have a computer making a set. Humans can't do this at this speed, but a human, the machine, the puzzle piece lands. It lands in the puzzle. It changes the shape of the puzzle. It connects some other parts of the puzzle you didn't know were connected. Maybe it's important, maybe it's not. But if it is important to who? Tell them. That's data finds data, relevance finds you. And that's really about helping focus human attention.
That's Jeff Jonas. He's the CEO of Senzing, and he's speaking about entity resolution. What's entity resolution? Well, let's just say the government is trying to prevent a known terrorist from entering the country, and the watch list has a slight name variation. Entity resolution then is recognized when two observations relate to the same entity. So how much of this is geospatial technology? Well, all of it is. So you won't want to miss this episode of OnPoint with Korem.
Jeff, great to see you. Thanks. Really appreciate you taking the time. Let's start off for people who are listening to this who may be puzzled about why we should be talking about entity resolution. And I know you can provide an easier answer and make that link between geospatial technology and entity resolution.
You know, it's interesting. This word entity resolution is really coming of age. It's had a lot of different words over the years used for it. I mean, identity resolution, data deduplication, record linkage, match merge, profile unification, all of these things, patient record matching, all these things are forms of entity resolution. So just to maybe define that first, entity resolution is recognizing when two observations about two different entities, like two different people or two different companies, are the same, even though they were described differently. One of the records is Jeffrey James Jonas, one is Jeff Jonas. Maybe the month and day and the date of birth transposed, or the addresses are messy. Maybe one of the records has an email and a name, and the other record, has a name and a date of birth. How can you figure out, and which scenarios can you figure out when two records are about the same person or related? Sometimes you can be confident that they're not the same people, but they're related because they live at they have the same home address and same home phone. So entity resolution is about finding duplicates within a data set and combining data across data sets. And it's primarily the latter that becomes super important to geospatial, because not all records have a lat long or an address. So, if your records are name and email address, or you got a phone number and a name, or you got an account number and a something, but you don't have an address and you don't have a lat long, then you can't place it in space and time. And so what entity resolution allows you to do is combine data, and what you can do is then inherit a lat long, an address and a lat long, a where, on data that's unlocatable in space and time.
So, I've seen some of the other presentations you did, and it seems like what you're referring to is context computing. I've got to put things more in context. Geography is one of those elements that's context. I've heard the term ambient geography, applied to that, like what's going on around me. And I think that's, if you could explain that a little bit more, because I think you're saying is you get a record and it looks like this record, but it's different, but it all matters. Context matters in that case. Is that a good way to explain it?
Yeah, maybe I'd start by saying the way, when I think about context, when I was at IBM, I was the chief scientist of context computing. So this is a topic that's near and dear to my heart. But context, better understanding something by taking into account the things around it. That's context. So, a really simple example is the word bat. Like you can see the word bat, but maybe you're not sure what kind of bat it is. As a fun example is, I ducked as the bat flew just over my head. Now in your head, you might be associating the flying bat, but I'm like, man, I never knew baseball games were so dangerous. If that's the second sentence, it redefines bad. And so when I think about information and context, I often think about it like puzzle pieces. Like this, this pile of data are the red puzzle pieces, and that pile of data is the blue puzzle pieces. Some of the piles of data are very geospatial rich. They're the gold puzzle pieces. By the way, I think geospatial data is analytics superfood. Like if you have one piece of data to wish for, it's when and where, how things move. It's incredible. But context computing and entity resolution plays a key role in this, is associating all these puzzle pieces. It's like the difference between a pile of puzzle pieces and then taking the puzzle pieces to the table and seeing how they fit. Putting the red and white pieces kind of near each other. It gives you a little more context. Actually connecting them to each other brings out an image. And the better of a job that you, by the way, this has a second parallel. If you only study the red puzzle pieces, you can't get that much learning. You want to have a diversified collection of information. You want to widen your observation space. And then when you put it all together, you get these really rich views, and then you make higher quality predictions.
So, I know you started your business a long time ago, and a lot of your success was due to detecting fraud at casinos. Can you put that in perspective? Like how did that happen? How did in that context, I don't know if people had a name or an address, but detecting fraud at a casino had to be related to the contextual component of an action at a casino.
Well, it starts with the actors. It starts with knowing who is who. And when we set out on that project, it became known as NORA, non-obvious relationship awareness. And its purpose was to help the casinos better understand who they're doing business with. So let's start with the observation space. You got people making hotel reservations. You got people checking into the hotel without even reservations. They just show up last minute. You have casino credit where you extend, you lend money to people so they can play. There's a loyalty club. You have your employees. You have people applying for jobs. They're trying to climb over the fence and get in. You've got vendors. You got people you already arrested. And then you've got people on a watch list published by the gaming regulators. It says, if you do business with these people, called the exclusionary list, we're going to take away your gaming license or heavily fine you. And so at the volumes that the casinos had, they really do need to know who they're doing business with, whether it's for a marketing and upsell or a cross sell or a compliance where your gaming license is at risk. And bringing all of that together on who's who, who's connected to who, is really a first step in assessing good news or bad news. Green light, red light, yellow light, right? Yeah. And a subtlety, by the way, that is missed is clever bad people don't use the same name, address, and phone on every record. Only the idiots do that. And so you have to be able to see through people obfuscating who's who. Right. And when you net it all out, I dusted off some charts, from the old days when I ran it the first time. And, you find things like, a vendor and an accounts payable manager that aren't geospatially near each other. I mean, they are, not just in a big polygon, but they live at the same address.
Yeah.
Right. And you want to know, in a case like that, it's smoke. You can't call it fire. Maybe it's been disclosed, but yeah. So there.
So one of the things you also mentioned, in one of the other videos was, and I wanted to get more of an explanation, is you said something like in regarding context commuting, data finds data, relevance finds you. In the context of big data, isn't that exactly what we're trying to do, is sift through the chaff of all of this data stuff? Mm-hmm. And I just find it, how much data do we really need? You always said you need more data, even bad data.
Well, there's about three things to unpack on all of this. One is things that are rare, like anomalies in big data. Things that are rare, there's a million rare things a day that happen. Like how often do you and I hang out on a Zoom, So just being rare in big data, there's a million rare things a day. So that's actually not enough signal. You have to look at other surrounding things about the kind of rare that it is. Another key thing is, I had this, I'll call it a discovery, because it came to me. I was talking to a counterterrorism intelligence analyst at an organization you'd expect working on stuff like that. And I asked this person, I go, what do you wish you could have if you could have anything? And she looks at me and she says, I wish I could get answers to my questions faster. That sounds very reasonable, Joe. Like, who doesn't want that? But, this is like just post 9/11, right? And it struck me so funny. And I looked at her and it just popped into my head. I go, what if it's not a smart question today? What if you have to wait 4 or 5 days or 4 weeks until more data's arrived? Then it's a smart question. What if you've asked the question too early? And she looked at me and said, that could happen. And then I freaked out. I said, but you can't ask every smart question every day. Like, you can't come up all your smart questions and asking them all every 30 seconds. She goes, you're right, I can't, apathetically. And I'm thinking to myself, we're all going to die. Like, her job's to protect the country, from bad things. And that's when the words popped into my head. Every piece of data that arrives is the question. It's kind of like, think of sense making. It's like, as fast as the days are arriving, you're seeing how it fits in the puzzle, and you can have a computer making a set. Humans can't do this at this speed, but a human, the machine, the puzzle piece lands. It lands in the puzzle. It changes the shape of the puzzle. It connects some other parts of the puzzle you didn't know were connected. Maybe it's important, maybe it's not. But if it is important to who? Tell them. That's data finds data, relevance finds you. And that's really about helping focus human attention.
So does the technology we have today allow us to do that? As data finds more maybe information, I always get confused with, this artificial intelligence and machine learning is going to find you the answer really, really fast. But it's not going to find it really, really fast if you don't have the right data.
Well, you have to have a lot of data for training, and most people don't have that kind of data. Then you have to look for other people to create training models, hoping they have the data you have so they can share their models with you. And that's one reason why it's a bigger lift. You can't just use those words casually and think you're just going to get gain. And by the way, it's kind of like self-driving cars. There was all that momentum and all that gain, and we thought overnight we were going to see self-driving cars. Guess what? Closing the last inch, not trivial. Yeah. So, some companies that have all the data in the world have the advantage of a sufficient amount of data for training.
So are we kind of fooling ourselves in that, all we need is more data? I'm going to buy location data from, I don't know, somebody's providing footfall traffic, and that's going to tell me everything I need to know to do my marketing. Or I've got a global data set of addresses, and I'm going to be able to link addresses to people. Are we just kidding ourselves with all of this?
I think everything you just mentioned is useful. It depends on which use case. But if you're trying to understand commercial real estate, and one of your data points is foot traffic to an area, that's great. Now, you might want to overlay it. It might be that somebody's holding large events in the parking lot weekly, and they're not going in the stores. And there's at the same time, there's these large afternoon music gatherings. So maybe that would be a false positive. You're like, wow, a ton of people go there and shop, but maybe they're just going to the parking lot and going to a concert and never going to stores. So overlaying secondary data just improves the quality of your prediction. But foot flow count into businesses is extremely valuable. Like if you're a hedge fund, if you're in commercial real estate, if you're doing lending, lots of markets for that. It's really about what's the use case, what's your mission, what's the right, well, I called it fantasy analytics, man. I can't tell you the number of times I go somewhere and say, what do you want to do with analytics? And they go, I want an ABC. And I go, well, what kind of data do you have? And they go, I got blue puzzle pieces right over there. I go, not even a divine being could use those blue puzzle pieces.
Yeah.
And find that. So sometimes organizations have goals in their analytics, like let's reduce fraud by 80%. The question is, in many cases, you need to widen your observation space. You know, maybe you need to buy some reference data from, like corporate hierarchies and beneficial owners in banking, right?
Do you think corporations have data and they just don't know what they've got?
Well, that's always the place to start. That's another funny thing, is a lot of places always start with, we just need more data from outside, but you look and they've got the blue puzzle pieces trapped in a silo. They got the red puzzle pieces downstairs in a vault. They got the yellow puzzle pieces up in the attic in a paper box. And you're like, well, maybe you should take better advantage of what you already know.
Yeah.
And so that's always the place to start, because you don't have to buy it, you don't have to get it. It's already your data. And by the way, if you have it, you probably have the responsibility to connect it. There's nothing like an organization that finds out they've been negligent. They found out they had the blue puzzle piece in one hand and the red puzzle piece in the other hand, and that they just never noticed. Like enterprise amnesia.
Right, right. So in some of the things that Sensing is doing in creating models, I think I've seen on your website, you're able to share models.
We're not,
right?
I wouldn't even say we're creating models. Oh, I'm gonna change that website. You watch. Bada boom, bada bing. Faster than a blank. You could say there's models, but the sensing technology is the same, whether you're marketing, doing bad guy hunting or risk assessment, supply chain integrity, voter registration, it's all the same. So it doesn't have any models about good news or bad news. It doesn't score things like, red light, green light, none of that. We used to do that as part of what we did, but the thing that we are uniquely good at is that entity resolution piece. Are these people the same, possibly the same or related? And then building that graph. Think of it like a scaffolding or a skeleton. And then on that, you drape events and transactions and locations and prices and blah. And that's context. And so what we do is we make it's a challenge for people that build software. When they're building software, it's do you know all the spellings of Mohammed or Dick Ricardo? We make that easy for developers.
But you don't do anything like a Neo4j, right? You wouldn't compare yourself as a competitor to that kind of a graph technology.
We are to Neo4j what peanut butter is to jelly. Ooh, would you like that?
Compliment? Is it a good compliment?
Oh,
I love peanut butter and jelly, right?
But only better than that is peanut butter and chocolate. Maybe I should have said that. The only thing. So Neo4j is you could say the most popular graph database. It builds a visual graph of how nodes are connected. And sometimes those nodes go from Billy to Bill to William to Willie. But those are all the same. And then it goes to Sue. So it looks like you're like 4 or 5 hops from Sue, but if you entity resolved it, you realize it's one hop. So entity resolution helps compress or consolidate synonym nodes in a graph database. So they work beautifully together. In fact, we have an open source project that takes our output and will publish it in real time into people's Neo4j graphs. There was just a company called Data Economy just announced the work they're doing with Senzing. That we build transmissions. People sell cars, we sell transmissions. And Neo4j would be another car part, but an important car part. So this company, Data Economy, doing PPP loan fraud products, has combined Senzing, peanut butter and jelly, and have a great product that help companies find, help banks find people getting 2 or 3 loans. Same company. Or companies that are no longer, you add some third-party data like Open Corporates, which is a registry of when businesses' licenses are valid. And suddenly you see you're giving loans to businesses that are out of business. So, but anyway, that's what happens when you take a graph database, entity resolution, and add some data. Then you get innovative products that find things more accurately.
So where does something like a Databricks environment fit with sensing? Is that it sounds almost too good to be true what Databricks is doing, right? I mean, they're trying to solve the world's cloud problems and de-silo information.
Yeah, Databricks, Snowflake, who else would come to mind? I'll just use those two. These are organizations that are helping you pick up data, transform data. I think Tamara's maybe another good example. But pick up data, transform data, and land data in a more useful form. In that workflow, you need entity resolution.
Mm-hmm.
And by the way, there's a couple reasons. One is if you're doing your own machine learning, what do you think is going to learn better? What if you tell the machine learning model it's 3 people, each with 3 transactions, each with 1 transaction? But what if it's really 1 person with 3 transactions? How different do you think the training will be? I'm telling you, hugely different, night and day. So entity resolution is important as a part of the preparation process. And by the way, around geolocation, now you're adding geolocation to records that didn't have geolocation. So now your models can take advantage of Now you can have a data set that's email address only, but suddenly because of entity resolution and other data, there's lat longs on there too. Right. Oh, now your machine learning models can produce geospatially aware models. And then when you're onboarding new vendors or customers, you can do better real-time, know your customer, due diligence. You can do continuous vetting on your supply chain, employees or workforce with entity resolution. So anyway, long story short, entity resolutions, yet just another, stool, a leg on the stool, right? Of the kinds of things you do when you're doing things like Databricks or Snowflake.
Just one last thing. I want to pick up on something you just said because it relates to some of the things that are things that insurance companies would do in terms of fraud detection, where you don't want to resell an insurance policy to somebody that fraudulently, acts, did something fraudulent in a past life, right? And you're onboarding this customer. Oh, this is a great looking guy, but out of context, you wouldn't know who this guy was.
We've seen that our customers report that. You see a banking customer fired from a big bank in Asia, and then they turn back up, let's say in Hong Kong, and then they turn back up in India. It's the exact same one you fired. There's one letter different in their long last name, and there's a different passport, and you just think you just got yourself a great customer. In fact, once bad guys get really used to how to, operate in your system, and you finally detect them after 5 years, they'll just wiggle right back. They've already studied you so much, they just wiggle right back in. We do something really unique called Entitycentric learning. It's a very different style of entity resolution. It's a lot more expensive to do in terms of time. We try to make it fast. I mean, it is fast. We do thousands of things a second, but it's a lot of extra work others don't tend to do. And it helps you find those people that are obfuscating their identity to be somebody else. They don't want you to connect this geospatial record with this record over there. They wouldn't want you to know that was them.
Right.
We have created a way to do that in real time in big data. And we just, by the way, Joe, we just let people download our entire product for free and try it. Like literally, maybe you would have seen that on my website. Like click here and try it for free. Right. Yeah, but it's for developers. It's for people that are trying to solve this problem in their product, or in their workflow.
Well, Jeff, we'll leave it there. I can't thank you enough. Always enjoy the conversation with you. And, another time I will continue to be educated. And so my questions will get better and better whenever I talk to you.
This has been great. What are you talking about?
So,
hey, reach out anytime. And by the way, I'm Jeff at Senzing.com. I answer every email, so of course I answer yours because we've known each other now forever and a day, but to any of your listeners, I answer emails. It can be about work or about triathlons or travel or whatever, but I'm very accessible. So
cool.
Yeah.
Thanks again, Jeff. Really appreciate it.
Thanks, Joe.
You bet.
Yeah.
Thanks again for joining us on another OnPoint with Korem. And if you like today's podcast, please leave a comment in the comment box where this podcast is posted, which could be Apple Podcasts, Google Podcasts, Spotify, or YouTube. I hope you'll join us next time for another On Point with Korem, where we'll get on point.